welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge.
Thank you, everyone. Ismael, I'm wondering if we can first start off with a bit about DeepProve's vision and how it ties into Lagrange's long-term roadmap.
Yeah.
So where do you see those two converging, and how does DeepProve relate to what Lagrange is looking to build in the long term?
Yeah, I love that question. So Lagrange fundamentally is a ZK company. We target the generation of zero-knowledge proofs across a wide variety of areas, and we prioritize based on relevance of application. And so when I started Lagrange 2 years ago, actually, no, sorry, 3.5 years ago at this point, there was one use case in ZK anyone paid for. That was EVM block space, ZK rollups. Now we are 3.5, almost 4 years later, and unfortunately, there is still only one use case anyone pays for in ZK, and that is EVM block space, right? Now, instead of having two companies, Polygon and ZK Sync, that sell EVM block space, we have 20, right? We have Polygon, ZK Sync, Scroll, Linea, Tycho, Succinct, Risk Zero, Valida, Next. I mean, I can go down a whole list of these. And so Lagrange really wanted to endeavor to do something different, to find a place where zero-knowledge proofs could fundamentally transform an industry that was not just a continual rehashing of the same problem space. And that's what DeepProve is. It is, in our mind, one of the first places where ZK can actually permeate outside of crypto and generate true business value in traditional sectors by being able to add verifiability, privacy, and security to AI inferences used agnostic of area.
Yeah, thank you, Ismael. It's really exciting that now Lagrange is taking the first steps to making these real-world use cases possible, and AI is really the first application that we're looking at. So super exciting time that we're in. I wanted to ask you more about the need for ZKML and why we need to prove the inferences that these models are producing, why we need to prove that they're correct. I remember in your opening keynote, you mentioned that a lot of these AI algorithms kind of now operate in this black box environment. So wanted to hear more of your thoughts on the true need for AI, for ZK verifiable AI.
Yeah, I mean, that's an amazing question. So we are entering an era of unprecedented reliance on machine intelligence, all the way through how we make decisions on a personal level over the trip itinerary I asked my chat GPT, all the way through how doctors are leveraging diagnostic models to identify rare diseases in patients. I mean, the fabric of our society is reliant on the output of foundation models. And yet, we have very little insight into, is the model operating correctly? Is the correct model being used? Is the model fair? Does the model have any biases? And there really is very little research actually being done to constrain what the models can in fact do. What we are doing is pushing forward a sector with very little safeguards in place for how the detrimental effects of that sector could influence our everyday lives. And what ZK does is add properties of safety, security, and verifiability to these AI models. At the basic level, to your point, that's a proof of inference. Is the result I am getting coming from the correct model? And do I have a proof that I am in fact getting that from the correct model? And now, a step beyond that is a proof of fairness, right? I've run 1 million inferences from this model on an input set corresponding to a bunch of different, people's characteristics, different races, genders, sexes, everything. And can the output be classified as fair, agnostic to all of those? And then you can talk about even further facing explainability, interpretability, all of these areas where you want to ensure the model's operating correctly, it's not hallucinating. This is where you need ZK within AI.
Yeah, and you mentioned about kind of its use in verifying the model itself. So how about situations in which the model itself is correct and fair, but what about in cases where the underlying data sets that are being used to train these models may have some biases attached? Can ZKML help assist with that part of the ML pipeline as well?
It can. I mean, that's the great thing about ZK. And I don't want to just be here shilling ZK like this panacea technology, but fundamentally any computation that you can execute can be proven with zero knowledge proofs. And so if you want to prove the model was trained correctly, what you would do is you would generate a proof of the fine tuning or a proof of the training process to show that with respect to the input data, this model was generated with these weights and these biases by training it. Obviously, it's a much more computationally intensive proof to generate the single inference, right? But it's still directionally something that ZK is in fact the answer for. So, take this commitment to this data, take this commitment to this model, take this model architecture, and prove that if you train this model architecture on this data, you get the following output model.
Yeah, it's really great to hear that ZK can be applied in multiple parts of this pipeline process. So that's really awesome. Also to hear that Lagrange is providing this framework for developers to use to, apply to these different, depending on what the developer is working on at the moment, apply to those different scenarios. And I also wanted to ask you a bit about kind of the convergence between ZK AI and crypto, as what Lagrange mentions as this watershed moment for the convergence of all these three areas with the development of DeepProve. So I'm wondering if you can speak about some of the implications that come with all these three areas converging together and what you see DeepProve's role is in this.
Yeah, so I like the way you refer to it as a watershed moment, because I think that is very apt. There are very few technologies in any sector that are directionally correct, right? That you can look at and say, okay, I know 10 years from now, 15 years from now, 20 years from now, 50 years from now, we will have more usage of that technology than we do today. I can't say that about most things, right? I can't say that about gasoline cars. Right? Maybe we have more, maybe we have less. People go up, but we also make more electric cars. You can't really say that about, proof of stake chains. Maybe we have more proof of stake chains. Maybe we have more proof of work chains. I don't really know. I can't make a bet on that. There are very few technologies you can say are directionally correct. One of these is AI. We know 50 years from now we'll be using more AI than we use today. That's a given. Another of these technologies is space travel, right? Asteroid mining, quantum computers, and ZK. We know for a fact that as you decrease the cost of computation and the overhead on generating a proof, and you can start getting verifiability and privacy by default, it becomes a foregone conclusion to make all computation verifiable, all the way from the cloud to everything in crypto to everything in between. And so when you take two directionally correct technologies, AI and ZK, and you intersect those, what you have is a convergence that you can also say is directionally correct, that will become increasingly relevant as both of these technologies independently subsume a larger portion of their respective markets. And that's what makes ZKML so exciting. We're seeing applications in crypto, everything from on-chain trading bots to wallet LLMs. And we're also seeing applications in traditional sectors, FANG companies, foundation models, hardware manufacturers, even healthcare systems. Major hospital systems have reached out to us about adding privacy to the use of diagnostic models. So that's what makes it so exciting, because it's a technological intersection that subsumes everything, as each technology subsumes everything.
Yeah, it's really exciting, and especially how you mentioned that now we can enable for more use cases to be held in other industries as well. Not just in a lot of our crypto native use cases, a lot of those are within DeFi, within the finance industry. But now, as you say, we can have some in healthcare even, and many others even in defense. So really exciting how we can use this convergence as a way to integrate to other industries. I also wanted to ask you some more details about DeepProve itself. And I wanted to ask you specifically on some more details about the developer experience. So for any kinds of builders or developers in the audience who are looking to prove their inferences or who are looking to use a ZKML stack, I'm wondering what kind of unique features does DeepProve offer and how it compares to, say, some of the other ZKML libraries that exist in the market?
Yeah, so DeepProve is, without a question, the most performant ZKML library in the market. And that's not just from what I'm saying, that's from independent benchmarks. So we put out our first set of benchmarks when we released the first version of DeepProve. And our benchmark said we're about 158x faster than our closest competitor. Our closest competitor got really angry and started saying, oh, you made up these benchmarks. Then the independent benchmarks came out one day that I didn't even know were happening, and we're 750x faster, according to those. So we're confidently 2 to 3 orders of magnitude faster than our closest competitors. And that is just a fundamental breakthrough in the performance of these systems. I mean, everything that we use within DeepProve is built from scratch in-house. Our chief scientist, Babis Papamanthu, is one of the co-directors of the Applied Cryptography Department at Yale. We have a fundamental research team with a bunch of fantastic contributors, people like Dimitris Papadopoulos, Shravan Srinivasan, Nicola Gai, and people who have long both academic and industry careers implementing emergent zero-knowledge systems and academic experience implementing ZK machine learning systems. And so that's why our prover is so fast, based on things like sumcheck, logup, GKR. It's just, orders of magnitude 2 to 3 faster than our closest competitor on the first version, and we expect even more soon. And for a developer, it's very simple, right? We want the library to be something that can generalize to any model architecture you build, anything from a decision tree to a foundation model. And what you do is you take an ONNX file representing your model, which has the weights, the biases, the model architectures, the model modules, etc., and you can put that into the library, and the library will be able to parse the ONNX file and spit out the corresponding cryptographic circuits required to generate proofs for that model architecture, as well as do the relative quantization of the model to ensure that it works over the right data range.
Yeah, nice. And really appreciate the what you mentioned about being generalizable to all different kinds of model architectures. And I feel like that really contributes to the end user's experience, just because so many developers in the audience may be using different models, may have different needs. So it's really great that you're providing that type of flexibility there. And it sounds like you're also really helping to abstract a lot of the details, especially when it comes to the ZK nuances away from the developer as well. So I'm wondering if you can speak more about what the end-to-end experience for a developer using DeepProve would look like.
Yeah, that's a great question. So, I'm going to say a controversial statement. The last 3.5 years, I've been running a ZK company, and every ZK event I go to, someone tries to explain on stage how ZK works. It's time to stop doing that, right? I can't remember the last time I saw OpenAI have a conference trying to explain how a transformer works. You should lead with the value proposition of what you build, such that people naturally use that technology because of something relevant that it does for them. And that's what we've tried to position DeepProve to do. To be a piece of technology that anywhere from someone who actually understands how it works all the way to someone who just wants to add verifiability to their AI, they can integrate it, right? You can think of this as a very simple library that you can plug into any existing model workflow that you have to generate proofs of that model. It's simple, it's straightforward, you can parse the model, you can generate the correct circuits, and you can leverage that within your flow. I really hope that with DeepProve, nobody has to understand how it works besides our team and those who also have a similar academic interest in cryptographic research. I don't want my users to have to understand how cryptography works. And I believe DeepProve sets the right abstraction level where that can be in fact the case.
Yeah, and that's really great to hear that, nowadays people who want developers who say want to use ZK or even DeepProve in this case, they don't need to know all the underlying cryptography, say, behind ZK in order to use it. They just need to know how to apply it to their application. They just need to know the business logic behind it. So really great that so many strides are being made towards abstracting these details and just simplifying the overall developer experience. I wanted to also ask you, just in the general ZKML space, we talked a lot about the advantages, but I also wanted to talk about some limitations and trade-offs. So right now, still the ZKML development is in its relatively early stages. So I'm wondering if there's any sorts of limitations in terms of the complexity of the models that can be used or the number of parameters that we can use these ZK proofs to generate from these inferences. Just wondering about the general limitations that, say, come with either the complexity of the model or, say, the number of parameters that can be used.
Yeah, so we actually, the new version of DeepProve coming out, let's say in about 6 to 8 weeks, will support a number of foundation models and LLMs that, let's say, are in the 10 or let's say 5 to 20 billion parameter range. We transparently expect that very soon we'll be able to support 50, 60 billion parameter models. Obviously, the proving time on those are going to be a lot longer than if you're doing a smaller model. But, that's a trade-off that you get by adding verifiability or a very large model. To take a step back and to make like a more meta point, I said earlier that ZK is a directionally correct technology, just like AI, just like space travel, asteroid mining, all these other, futuristic quantum computers, all this other stuff. And it's very easy to look at these technologies and say, hey, it's too expensive today, it's too cumbersome today. But the good thing is we know that all of these will get substantially cheaper over time. And to put that concretely, when I started Lagrange 4 years ago, ZK was about 4 orders of magnitude more expensive than it is right now. There was not commercially available ZK VMs. Most of the ZK EVM teams had yet to hit production. There was no GPU acceleration. There were no ASICs for cryptography. There were no general purpose chips for cryptography. The infrastructure was primitive 4 years ago compared to what it is today. And yet, every year, year after year, we've seen a 1 to 2 order of magnitude decrease in the cost of generating a zero knowledge proof and a latency. And now we look at ZKML and we say, okay, this year we'll probably have about a 50 to 100x overhead on generating a proof of a model compared to just natively running the execution. Which transparently that's expensive, right? You can say if it costs $20 to generate a proof for, 04, that's going to be pretty expensive $20 to generate an inference for 04. It's going to be pretty expensive if you multiply that by 100, right? Probably not practical. But if we're seeing it get faster and cheaper by 1 order of magnitude per year, how far out are we? 1 year, 2 years before you can do almost any type of commodity inference within a ZKML library? We're seeing faster than almost any other space we converge to a price point when almost all computation, specifically AI, will move ZK.
Yeah, absolutely. And as you say, it's really important to consider, how many orders of magnitude faster are we getting? And this is really a journey. It's not like we can just say, reach the endpoint, have near, even for ZK proving, have achieved real-time proving in just a year. It takes time. So yeah, really important to keep that in mind. I also wanted to ask about some of the optimizations that DeepProve is looking at. I know that you guys are looking at, for example, hardware acceleration and also distributed proving in order to increase the scalability. So wondering if you can dive into some more details about those optimizations that you're looking at.
Yeah, so DeepProve was built from scratch within Lagrange. It's based on SumCheck with GKR and LogUp. Very performant, very fast, fastest library in the space by far. And the advantage that we have with DeepProve is that we didn't rely on a open source commodity available circuit library. We didn't grab Plonky 2 or Plonky 3. We didn't grab Halo 2. We really rolled the whole thing from scratch, and that's what made it so fast. And it means that now we have an opportunity to accelerate even further. right? So Lagrange as a company has done distributed proving for the better part of 18 months at this point for other types of proving applications that we do. And DeepProve will soon support that. Hardware acceleration. There's great work done by several GPU teams on being able to move Goldilocks field onto GPUs. The prover we use does use Goldilocks field. And so that should be moving within a month or two onto GPU, which will add another probably 10 to 100x performance increase compared to the CPU proving that we're doing right now. And then just general improvements that we get. We're going to probably change the commitment scheme we do. We're using basefold right now, so we're going to change that at some point. It'll probably bring proof size down. There's a lot of optimization at the cryptography level. Like, what I'd say is, the same way a company like OpenAI just went out and hired all the best AI researchers possible to build their models, we've done that with ZK. We've hired from academia, from industry, from companies like ZK Sync, Protocol Labs, Mina Protocol, just really everywhere we could. Consensus, everywhere we could. And then we also hired from academia. 2 professors on the team, bunch of fantastic researchers. And the result of that is really just an incredibly performant underlying system that we expect to only get faster.
Yeah, incredible. And I also wanted to ask about some use cases and applications that are being built either right now with DeepProve or maybe some use cases that you would like to see being built with DeepProve, or any that you see have maybe a lot of potential in, any specific ones that you're excited about?
Yeah, so I would start with saying, there's a couple kinds of applications of DeepProve that I think are right down the center. That it's like very easy to conceptually see how those are going to be used. And then there's some that are on the other end of the spectrum that are very, very hard to envision. But you go, hey, that would be really cool if it happens. I hope someone makes it happen. And so the really easy to envision ones are like just stuff in crypto that like we use AI for now that we could make verifiable. So like DeFi agents, right? Hey, this agent trades on chain. Maybe instead of centralizing the trading bot, if it has $100 million, it should use, a proof so that nobody can rug it. Pretty easy to imagine that thing being built in the next couple months. People are building that with us right now. Then there's like, a little bit farther out, which is like, okay, can you take a wallet, Coinbase wallet, MetaMask, etc., and embed an LLM in the wallet such that you can specify in natural language how you want transactions to be formed. I want you to buy me ETH, and I want you to LP that into UniV3. Right? Well, if that model is being used to generate your transactions, you need to ensure that the correct model is being used and is not somebody in the middle just sending you a bad transaction to rug you that you're going to sign. And so, okay, easy to imagine that would need a proof that you verify client side or verify in your wallet before you sign into transactions. Now a little bit farther out, right? Deepfakes, content moderation. When you start being able to have models classifying images as containing violent content, illicit content, not safe for work content, etc., or deepfake content, you can start generating proofs of those models over an image set that can then embed the proof into the image or the set of images. Where that's relevant is you can start having content self-certify itself. So you can be an image upload site, the centralized UI front end, and you don't have to independently content moderate. You can just accept images that have self-certified themselves as moderated. That's fantastic. You just verify the proof, very easy, show the image. And then we have stuff that are really far out. There's hospital systems. There's FANG companies that we work with. How can you start taking diagnostic capacities? How can you start taking the use of models in critical systems, aerospace and defense, and start adding verifiability to that? Right? How can we ensure that systems that even maybe defense relevant that require certainty over the models that are being used in them are in fact verifiable or privacy preserving?
Yeah, nice. And it's really incredible to hear the extensibility within all of these. Yeah. And, verifiability at the end of the day can really apply to any industry, to anything. I also wanted to ask you, so as we're seeing more adoption for ZKML, more and more presence there, I'm wondering if you suspect there will be any sort of regulatory hurdles that we'll come across, or on the other side, if we're able to, say, prove these private inferences and maybe privatize, say, in the healthcare industry, patients' data? Would this be more in favor with these regulatory bodies? Just wondering about your general thoughts on just the regulatory standpoint with this.
Yeah, that's a fantastic question. So I actually think that we are going to see regulation favor ZK machine learning. I think it's going to become an imperative that you have privacy-preserving inference of some type, and I would hope it's ZKML, that will be used. Like the idea that you're going to have diagnostic capacity, healthcare capacity, scientific capacity, and then just general everyday user technology that isn't verifiable and isn't privacy preserving is rather concerning. Like I can't see a world where US consumers would be comfortable using non-US developed models like DeepSeek at scale if there wasn't certainties that are mathematically guaranteed over privacy and correctness of the model. And I can't see that, you know, that countries that are less US aligned would be comfortable using GPT or similar technologies for the same purpose. I mean, what was it, Italy outlawed ChatGPT? I mean, over privacy and security concerns. I mean, there's real reasons why you need a model to be provably correct and provably privacy preserving if you want it to operate correctly. And you can think about, like, you know, I gave this example earlier of MSF, you know, Doctors Without Borders, but decentralized, right? You have diagnostic models that are being able to identify rare diseases in emerging markets. How can the government of that emerging market trust that, you know, the healthcare data of their citizens is not just being mined by a foreign-controlled corporation? How can they determine that, you know, if they don't sign a rare mineral contract, the foreign corporation won't change a parameter and damage a bunch of the health of the citizens? I mean, when you start talking about, like, international relations and how AI fits into that, you start needing verifiability and privacy-preserving properties, because functionally you are operating in an untrusted environment by default.
Last question before we end today's interview session. I'm wondering, Ismael, if you have any sort of advice that you would like to give to anyone in the audience, any developers in the audience, and also for those developers in the audience, if you have any next steps they can take to get more involved with DeepProve and Lagrange.
Yeah, I mean, I would say two things. I'd say, firstly, if you want to use DeepProve, you can use it today. You know, it's on GitHub. You can use it for non-commercial purposes. You can benchmark it. You can experiment with it. You know, we always promote people doing that. You know, we always love feedback. We hope people go and try it and suggest some great applications to build on it. And so I guess the final message I'd give to everyone is, like, I would think through where you want to add verifiability into machine learning within your existing industries. What I really loved about this event and how it was organized, I mean, obviously credit to House of ZK, credit to Anna on our team for a fantastic job organizing this, was there were so many bright minds in AI who I don't think ever considered, previous to the last couple months of DeepProve, you know, being sold in market, like where they'd want verifiability in their sectors. When we talk to Web 2 companies, they rarely understand that even the stuff that we can do at ZK is possible, right? It's like, you know, oh, I thought we were decades away from that type of thing. And so I would really think within your respective industries, within where you work, where can adding verifiability be easy? Assume verifiability was default. Assume privacy was default. What could you now do with it? That's the message I want to leave people with. Don't think about the ZK, think about the application, and think about, hey, if I just assume I have these capabilities, what am I going to do with it? What's the next step?
That's great advice. And, you know, as you say, it's very exciting that we're now coming to the age where we can have verifiability, where we can have privacy as defaults, and something that, you know, users don't have to consciously think about as well. So really exciting strides that we're making. And thank you so much, Ismael.
Thank you so much. Once again.